So I thought I'd run through a little side project that I have with the solar hybrid that I just set up here, and that is the generator. Dry contacts, how I managed to get the generator to start and stop with the inverter, since the inverter just has a dry contact on it. It's closed, it says run generator. It opens, says stop running generator. Unfortunately, my generator, which is a Westinghouse, what is it? It is a Westinghouse WGen9500DF dual fuel, and it's just a momentary. So you press this once, boom, it starts. You press it a second time and it shuts off when it's in run mode. Run mode is turning the switch on right here. So my issue has been that the inverter just does that dry contact thing. When it says generator, it pushes the button, the generator runs, and that dry contact stays closed until it's calling for generator to be off. Well, when you let go of that contact, it's the same as just taking your hand off the button. So the generator keeps running because it's just seen a single push. So the trick here is to get the inverter to just send a single push button to the generator to tell it to start, and then a single push button to tell it to stop. Well, it doesn't have that functionality in the software, which would be nice if they wrote that in there, and it would have negated the need for this whole thing that I made. Well, what I've made is this guy. And what this consists of is an ESP32 running ESPHome. It's all YAML based. A relay. This is a relay that clicks to close the contacts on the generator start. Some terminals for -5 volts, well, 0 and +5 volts. And then this relay right here, which takes a 5 volt signal from this power supply that I have plugged into the generator. So right here I've just got a 5 volt wall wart, and when the generator is running, it turns on, sends 5 volts into this relay right here, and that tells this program that the generator started. So a couple of other things, I've just got a little bypass switch here. This is the same thing as the inverter closing the dry contacts, which is how I've been testing it. And then this is a 5 volt power supply. It takes 120 volts AC, puts out 5 volts, that runs this whole deal. And then the program, it has a couple of functions. So when the program sees the inverter call for generator, it goes ahead and closes that relay for 2 seconds, which is the same as a single press. Then it lets go. The generator runs through its start cycle, and with any luck, it starts. When it does, 5 volts comes back through that power supply into this relay, tells the circuit, hey, we're running, all is good. If it doesn't, then it goes through a counter, and it says, okay, that was first try, because this will only try for 4 times, I think, and then it just errors out until you press the button again. You press the button again, and it goes through the start cycle again until it starts, or you shut it off. So I have a counter. It'll try that 3 different times. Hopefully the generator starts within one of those. Usually it starts on the first or the second, its own iteration, not second iteration of the program. Anyway, what I need to do now is I need to try to get out of the shade here. Why don't we turn this light on? Boom. So I've got dry contacts that I need to get set right here. That is just 2 wires, and they're going to run, and I'm going to bring them in to 1 and 2 here. 1 and 2. Those are the contacts I need for the inverter, and that's the same as me throwing the switch. It's just picking up that close contact. So I'm going to run some wire really quick, and then I'll show you how it all works. All right, so I have, the wires are done. So I have the dry contacts coming in right here. I want to be careful because that's my emergency stop. And I don't know, there might be a little bit of voltage there. And then for this box, I've just got this gray wire coming in. I'll staple it up later, but it comes in, connects to pins 1 and 2 right there, which should do the thing. Now I don't know if I can run the generator manually through the interface. There is a button in the app, but I'll tell you what, the app is terrible. So I'm going to go ahead and put the generator in go mode, which is just like that. It's all connected. I'm going to see if there isn't something on the interface here that will let me do something. I don't want to go through the process of saying, hey, my batteries are low, and start it. So what I'm going to do is I'm just gonna fake it. No solar. That's sad. All right. Anyway, so what I'm going to do is I'm just going to I'm going to fake it with my switch. It does the same thing. The switch is connected to the same pins 1 and 2 here. This is just the other side of it where I have the generator coming in. So watch and listen, and you will see what happens. So I'm going to flip the switch on, which is basically the inverter saying, hey, I need the generator running. You'll see this relay click, see a light on it for 2 seconds. That's going to send the signal over. Hopefully the generator will start on the first or second iteration, and then at some point you'll see this light on this relay come on. That tells the system that the generator is running and it doesn't need to try to restart it anymore. So here we go. It's all running. Now I'm going to shut it off. There it is. So yes, that does work, and I knew that worked because I have tested this before I had this in place. The generator isn't really connected to any of this yet. I do have a generator connect kit and this Chareverter GC, which is a 100 amp charger that's going to take 240 volts out of the generator. I'm going to be tying it directly to these pins right here on this battery, and it'll basically charge both batteries when the inverter needs it. So if my power goes out and the batteries run down to whatever percentage I set, 10, 15%, it'll go ahead and kick on, and it'll charge them up to a value that I also can set, 100%, 80%, whatever that is, until the power comes back on. And it'll just continue to do that until the power comes back on and everything is happy, or the solar takes over and is able to charge the battery. So that's a little rundown of this system. I'm going to go ahead and probably not set up that Chareverter today because it's late, it's dark. I just wanted to run through this. I am going to show you the program, kind of really simple ESPHome type YAML program. You know, you're all welcome to use it. Any of the parts I'll probably go ahead and include in the description down below, because I'm sure that I'm not the only person that's had this issue. I know for a fact that there was another person on YouTube that had hijacked the remote control, which this has as well, and he used some timer relays to do the same thing. But I like my solution here a little bit better. It's a little more elegant. It's got some backfeed. It's got some timeouts, and it won't sit and try to start the generator when the generator's out of gas, those kind of things. So if the generator's out of gas and it fails to do the start thing, this will actually enable an input on the ESP32, which I can then see in my Home Assistant, which, by the way, all of these things are connected to my Home Assistant. Speaking of Home Assistant, I just got an alert saying the generator's running, so that works. But this is the generator screen. Oh, a little bit of reflection there. That I can actually start the start relay manually by clicking that. and it will show me these, oops. It'll show me the status. So if I go ahead and, in fact, let's do it. Let's put the generator in start. Actually, yeah, let's do this. I'm gonna flip the switch. And there it is. And there's an alert right there saying, hey, my generator's running. So pretty cool. And Mr. House, I keep calling it Mr. House because that used to be my home automation. Home Assistant has no programming to run this. This is all contained within that ESP32. I've just tapped into the inputs and outputs so that I can see them and I can create alerts around them. But anyway, I'm going to button this up here, and I'll put links to most of these parts. By the way, this DIN rail and this case I had was something I already had lying around. It was something from Solar Edge that my consumption meter came into. By the way, I've got a little bit of a little LED on the front just showing me that it's getting power and that things are good. Just taps into the 5-volt pins on that ESP32. Anyway, comment if you have any questions, or if you want the code. I may just provide it in the section of the comments, so anybody's welcome to use it. I would like to hear back from you if you do use it. I think it's pretty cool. Thanks. All right, I'm on a little detour, and my hair today has just been nuts. Pay no attention to this. I need a hat. I hadn't seen anybody do this with the EG4 Chareverter CG or GC. It comes with this. These are 4-aught wires. And of course, everything on the inverter and the batteries that I'm working with are, what are they, 2-aught, I think? 2-aught wire. And so what I want to do is I want to plug this right into the batteries, or at least one of the batteries, depending on where. Well, my generator is probably going to end up closer to the inverter side, so it's probably going to connect to the primary battery. But that is what you get to connect them with. Didn't make a lot of sense to me, so I ordered from Signature Solar, along with the rest of my stuff, these. These are the ones that do fit the batteries. It comes with an internal and the male and the female lug. So it looks like you've got the battery side, and it's got a nice big terminal lug on it in case you want to use them for something else. Maybe you've converted a stack of server batteries over to this type of, I think it's Amphenol connector. Anyway, so the way it looks like they operate is nice little weather seal on them, a wire squeezer, and a crimp. This looks like a crimp end for big wire. And what we have is much smaller wire. So I've been thinking about this and how I'm going to tackle it, and I probably get one shot at it, so I hope this goes well. I figured I better record it just in case it does. So the first thing you want to do is make sure that all of the bits and pieces here are already on the wire, because once you do the crimp, you can't get anything on that because you can't get anything over this side here. So let's get a look at my workbench here. This is a sign of a busy guy. Man, I'll tell you, I am tired today too. So I'm gonna cut that off, and I'm going to strip it back. In fact, I'm gonna strip it back a fair amount, like maybe even more than that. Looks like these go way in there. So I want to almost double that amount. So maybe there. Be careful when you do this that you don't cut too deep into the strands of the wire. Of course, you could use wire strippers or a utility knife or something more proper. But I've been doing this all day with these, so that does not want to come off. See if I can stretch it off. Okay, it's coming, but I wonder if it would have been better if I'd done a little less at a time. And you see I did fray some of these wires. There we go. Alright, so I'm going to get rid of all these that I broke. Get them out of the mix. And what I've been thinking is that with a good twist and a fold, that they might fit and get crimped in that barrel. So I picked up this guy, and I have not used it yet, but I think it's pretty straightforward. You change the dies out to the size that you want to crimp to, and I'm betting, let's see, 2 watt. That's what it says. Might have to go a little bit smaller because that wire isn't quite even folded over. Okay, put the dies in here. Locked bolt back in place. And then you put in your stuff. I think I should have put my stuff in first. Just put in the stuff. Then the tool. The die, excuse me. And the bolt. And then hopefully, holding that wire in there, let me pump this up a little bit, so put it in the work mode. Get the die just touching. And crimp it down. Wish me luck. Just grabbing the wire. Okay. I think that's working well, actually. So let's release it, and I'm going to scoot it down and do it. Well, maybe not. Yeah, I'm going to do it one more time. Back in work mode. And I am going to get part of the insulation in this one, but that'll actually help retain this wire in here. I think I'm going to go one. I think I'm going to go one die smaller. So I'm going to go with the 50. Give it a good squeeze, because that looks pretty good, but I don't think, with the amount of current that's going to be going through this, I think it'd be better to get it nice and tight. So hopefully we can do this in 2 stages here. Drop the 50 in. A tool like this isn't something I'm going to use very often. I would make battery cables for cars, that kind of stuff with it. Okay, I'm going to tighten it up. Lock it in. That looks better. One more time right here. I don't know if you can see that. Hopefully you can see that. And voila, I think that's going to work great. Got a little extra squeeze out. That is nice and crimped. I think I'm going to get rid of this excess. I never thought there'd be squeeze out on metal, but let's get rid of that. Diagonal cutters for that. Yep, I think that's going to work great. So now we'll put the wire grabber back on there. And you can see it doesn't actually squeeze around the wire there, so it's important that that crimp is good. But now this guy, this guy's ready to go. That fits the battery side. So, Chareverter side, battery side, done. Okay, let's do it one more time. Bada bing, bada boom. Squeeze out, wires in there. Perfect. Put these back in here, they were stored in there. Okay, this is a ferrule hydraulic thing. Hydraulic crimping tool. And yeah, it works great. This wire's in there. Just gonna trim these up a little bit. I don't think you have to, but this one's definitely sticking out a little far. Okay. There you go. And now, Chareverter You plug right into the EG Power Pro or the indoor wall mount battery. There you go. I know if I say I'll leave links down in the description for this tool and these ends, but I'll probably forget. But if I'm editing this, remember, links in the description. And then tomorrow we'll get back on the big project. And yes, I will wear a hat so I can see. Thanks.